Hi, welcome to DCO. My name is David Capetti, and in this video I'll be sharing with you how to create this pavilion. It's an exercise in understanding how to use random points intersecting geometry to create pavilions and designs that would otherwise be very difficult if you didn't use parametric modeling. Let me show you here. Going into the space, we create the overall form, the subtraction on the inside, and then the openings for the outside. This is not necessarily going to be the most beautiful building, but what it will do is show you how this program works. I'm going over all of the steps in detail, and at the end I show some extra things that can be useful to further kind of enhance the design here. So thank you very much for being here. Hopefully you're going to find this interesting. I post videos like these every week where you can learn how to use parametric modeling for architecture and just learning how to use 3D modeling in a different way. So hopefully you're excited about that. Thank you very much for being here, and let's jump right in. All right, so the first thing we need to do for this part is create the area of where we're going to be creating our design. So we'll start here by creating a rectangle, and we'll go here to rectangle component. This is going to have X and Y sides and also a plane where we can locate it. So we'll start with X and Y. Let's go here to 150 in the X and 150 in the Y. This is going to be the area where our design is going to be located. Now we can take this rectangle and we'll go here to, well, there are different ways that we can populate this with random points. We could either go to populate 2D, populate 3D, but we need to turn it into a surface, or populate geometry, but we also need a surface. So we'll use populate 2D. And this is going to be, this rectangle is going to be the region where those are located. Now we can pick how many of these points we want. So we'll go here to 30. And so we have 30 randomly placed points on this rectangle. Now what we need to do is create a seed. This is going to give us other options for 27 points randomly located here that are different than these. So if we go to 3, you see that every time we switch this slider where it says seed, we're going to get random points moved to different spots, but we're still going to get 27 points. So at this point, what we're going to do is create a field of spheres on those points. So I'll go one step at a time so I don't confuse you. We'll go here and create a sphere. Wrong one. This will be the population, or the points are going to be the base, which means that it's going to create a sphere at every single one of those points. All we need to do now is change the radius. So let's go here and give it a radius of maybe 15. And if we want to have more decimal points, we can do 15.5. And this will give you from 0 to 100 and set it at 15.5. But if we want a custom slider, we can say from 1 less than 5.5. and then less than 30. This way it goes from 1 to 30 and sets it at 5.5. Now we see that we basically created a field of spheres that are all changing according to this slider. Now what happens is, since they're all the same, they're not going to intersect in every single instance. So what I want to do here is show you the power of using random numbers to create this field and give it a variety of sizes, not just being 25, because we have 25, we can change that, but we want 25 of them, not just with 26. We want a random set of numbers, maybe between 5 and 30, so we can change all of these and have them be randomly different. In the same way that we have random points, we'll be using random sizes depending on a specific range that we create. So at this point we can clean it up, or we can keep going, and at the end I'll probably clean this up. Sometimes I do as I go along. If it gets too long, I do come back and organize some of this information. Otherwise, it gets a little bit confusing to see what the sliders do. But with this, now we want to introduce a random set of numbers. So this slider gives us just one number. So we'll create here a random set of numbers using this random component. And we'll be using this number slider again. So we'll unplug this. The range is going to be from 5.5 to 25.7. And we'll do this by doing construct domain, which will give us the start and end domain that we can use as the range of numbers from 5.5 to 25.7. Those are the range of numbers that we want to create. The number is going to be how many random numbers you're going to create between those two. Well, we know we have 25 points. So this is where we'll take these 25 and use that as the number of random points we want to create because we have that many number of points. Here we can also introduce a seed value, which is going to randomize the numbers for the height. And so now if we take a look at the output of random numbers, we'll see that we have 25 values starting from 5.5 and ending at 25.7. And it's created 25 just random numbers between that range. So what we can do is rather than having one static number like 25.7, we can go to these random numbers and notice that now it's changed the scale for all of them. Now we see that maybe 5.5 is a little bit too small. So this is where we can increase some of the size of the start. So if we go here to a large number of, or possibly change this one to 50, and then we'll delete this slider and just copy this slider. Now you see that it got really small. Well, that's because this starts at 0. So it's going to start at, the smallest one is going to be close to 0, and the biggest one is going to be 25.7. If we do the same, well, they're going to be the same. But if we increase one and leave the other one a little bit smaller, now we're starting to see the power of using those random numbers, that we can change and remap some of the numbers to be what we want. Then here we'll go to seed. Maybe that's not the exact configuration we want. Maybe we want more. Maybe it doesn't fill in the spaces where we want it. So this is where we can use some of these sliders to get different iterations. And this reminds me a little bit of AI, where you can get a different result every single time, and it's going to be random just using a slider. And that's because we programmed it to be this way. So now that we have our design, let's say this was going to be our design, I do want to bring in a scale model of a person. So I'm just sliding this in here. I'll go to insert, hit OK, hit OK, hit OK, and then I'll go to 0, enter, because I have it at the origin point. Now we see that this is the size of a person. So this is going to be like a larger pavilion type design created with a bunch of spheres. And the scale is fairly large. We can always decrease, of course, the size of the design. If we want it to be smaller, well, then we need to decrease maybe the size of some of these. And then decrease the point count if it's too much. So it really does depend on how you want your design scaled. I like to use the scale person for that. So with this, now we know that, okay, this is an interesting design. Now we want to bring them all together. But before that, we actually need to split them in half. Let me show you how we're going to do that. We're going to take this rectangle, we're going to turn it into a surface. So I'll go here to boundary surfaces. Now we're going to take this, and there are different ways of doing this. So this is just one of the techniques that I like to use. Basically, scaling this surface relative to its center point. So its center point is going to be determined by first the surface, right where the rectangle is, then the surface center, or the centroid, the geometrical center. Then we'll take this center, go to the center location, and now we'll plug in our surfaces into the input, and our factor is going to be more than 1 because we want it to be larger than this sphere. We'll just go 2.5. Now we're going to take this surface that we've scaled. We can disable the preview on all of this, and we can take this and use that to split or to intersect with all of the spheres that we have here. So I'll go here to extrude. So we'll take the surface, we're going to extrude it past the tallest one. So in which direction? Well, in the Z direction, because it's going up. Then we need to click or plug in the factor. What is the factor? What's the biggest one? Well, we know the biggest one under random, this is going to be the random size. 28.9 is the biggest number. So that is what I'll use to extrude because it'll go past it. Now I do like to add a little bit more or multiply by 2 because that ensures that it covers it. So this part is a bit strange. It might be a little strange if you're fairly new at this, but what happens is if you multiply by 2, the number will always be larger than the original. It's not going to clip it, but this form we actually won't see again. So it's okay if we have it twice as big because for the most part it's going to be, the preview is going to be disabled, and you'll see this here. So I'll take that bottom surface, disable the preview. We'll take this sphere and this box, and where they intersect I want to keep. So this is where we use solid intersection between the form, the outer form, and the spheres. Actually, it might be the opposite. So the spheres and then the bottom one. And so now what stays is the top part of the sphere. So let me show you that. What happens is at the moment, we have a lot of overlapping information. We don't need to preview all of it. We only need to preview most of the stuff towards the end and the stuff that we really are using to extract our design. So this box, we don't need. So I'll go here, disable preview, and you'll never really see that again. Then we can take these spheres and disable the preview. And what happens is now we have a field of domes that is intersected with this box. So what we can do, one of the other things we can do is take all of these spheres and move them up so they don't intersect halfway. Maybe they'll intersect a little bit down, and sometimes that is a feature you want for your domes. You don't want them to be perfectly sometimes half. You want them to be maybe a little bit longer. And you'll see that with geodesic domes too. So with this, let's go to sphere, and we'll go to move in the Z direction. So we're going to move these up. And we're doing this before the difference because we are going to plug in what we move into the difference. And I'll go here to 1.5. Now you see that we've moved it up by 5 feet, but we haven't intersected it yet. So now it's going to take on this form. Perfect. So at this point, now we have all of them, but we do have them overlapping. And unless you want the rooms on the inside, there's something specifically that we could do. But what we're going to do is actually union all of this into one solid. This way we have the inside spaces that we can use. So we'll go here to union, solid union, and all of these will be plugged in, and we'll flatten the input to make sure that it comes in as one long list. Although it already was, I'll go to disable preview, and we're seeing that, wow, okay, now we're getting a few other results. But the cool thing about this is that we have interior spaces that can be used, and we can always change how many rooms we have. We can also change the configuration randomly. And some of these spaces are independent, create some courtyard, interesting spaces. So this is one of the exercises that I wanted to share because it's so useful to see how you can use random points, random numbers to create random geometry, which looks complicated, but technically we understand what the steps are. So we're able to kind of create these things in a script. With that being said, we're not done yet. We have the solid, but now this is what happens. We have moved up the spheres. We've intersected them, but now we need to create the walls to subtract from the overall form. This part is a little bit tricky to visualize, but you'll see here that we have all of these random numbers and that create these spheres. Well, what if I create another set of spheres like this on the same points with the same number, doing the exact same thing? Then we're going to also move it up. So we're going to take this, copy it down. So tap Alt, and now we're going to move these up. So we're basically copying the exact same thing. Let me show you why. Because now all of these random numbers are going into the radius. So what's happening is the radius is actually the same for both of these. We need this radius to be smaller. So all we need to do is subtract the size of the wall, minus 1.5 or 1.5 feet. So we'll go random points come in. The first value is 25. Well, now the output, the first one is 23.8. That's because it subtracted this much. So we can plug that into the radius and see that, oh, look, we now have this radius that has been moved up. And it's subtracted, so it's smaller than the original sphere. So what this does is we can now come in here, take the solid and go to difference. Solid difference between the spheres and the outside form. So now let's apply color to this. So let's move this to the right location. Now I'll go here to custom preview. This will allow me to give this color, and then I'll go to swatch or color swatch. We can see it a little bit more clearly this way. So these are interior spaces. Let me put the scale person in there. Zoom select. Now we'll do clipping plane. Vertical. That looks like. We're able to see through those. Now this one's independent and that one's independent, so maybe that's kind of cool if this is like maybe an outside bathroom or something. Let's go back to points. If we increase the points, that will update. Now there will be maybe some small things like this. That's due to too many overlaps. So if I go to 18, but just increase the size from 29 to 35. Okay. So at this point, we've created the pavilion, but now let's move ahead and create the rest. So for the next part, we need to create openings for people to come in. So this is where I love parametric design, right? Because we can come back to previous steps where we've created a portion of our design, and we can reuse it to create other aspects of the design. So now let's go into it here. Here we have a sphere, and let's see where I can show you. So we've moved these spheres up, and where the sphere intersects with this surface, not this one, the scaled one, where that intersects, where this and this intersects, that is what I want to keep. So between those two, we'll go to intersect, brep with brep, because this is a boundary representation of the plane on the ground, and this is the boundary representation of all of those spheres. Do you see how they are overlapping here? Well, now we can disable the preview on this so you don't see it. This stuff. Now we need to put all of this together. So in the same way that you have solid union, you have something here called region union. Notice that it comes in with this dashed line, which means that it's grafted set. So we'll flatten it here. And notice that now we have only the outside face of it. So with this, here, disable preview. Trying to see if I can take this. I just want the outside of it. So I'll go here to yeah, okay. So we'll go to item, list item. This way I can pick one of those curves. It picked the outside one first, which is good because that's the one that I want. But this is something that might need to be changed. So we'll go to 3 here, bring it back to 0, which is what that index is. We can change it to other ones. That's not the point. The point is we want the outside one, and that we want to divide using a curve. And we'll have 10 openings. So we'll go to 5, 1 less than 5 less than 20. So from 1 to 20 puts it at 5, or somewhere in between. Why? Because that's going to create the number of openings. So where those are located, we can also do random, right? So kind of going with the theme of using random, we can also use populate geometry using a curve. So I can populate this randomly with random points throughout and just say I want 5 random points throughout here. That's another possibility, but I want to show you with this one, just being able to subdivide it evenly. We'll take this and we'll create another sphere. So we can go back here. We'll just create our own here. We'll go to a sphere. Use the points as the input. The radius is going to be at least 8 feet. So we'll say 15. Let's do that. Less than 7. 7 less than 12 less than 20. So that's going to be the range of numbers here. Can we randomize them? Yeah, but that would not necessarily be the point for the opening. The opening can be regular, but the overall form can change. So what do we do now? We can hide all of the steps that we took to get to this location. We can bring back our design and subtract it from it. Now, in the same way that when you create an opening, maybe like this won't look as great as when you move it, we'll copy this, tap Alt, because we can copy this movement up in the Z direction by 5. Now we can disable the preview on that and preview this. Now we have the ability to move this up and down to change the opening kind of location, right? So we'll go here to now, difference, solid difference, and we will be subtracting from the overall form the doors. And if 8 is too many, maybe 5. So at this point, this is the portion that I wanted to share with this voiceover tutorial. At the end, I will be sharing some of the other iterations that I created before this that have other alternatives, but for the most part, this is going to show you the power of creating intersecting geometries and at the same time using subtraction. So overall, is it the coolest design ever? Maybe not, but what did we learn here? Well, we learned to create a pavilion using random points, spheres, subtraction, and intersects. And here we are. We're able to create a pavilion that you can access the inside, has multiple openings, and creates a very unique experience that would be very difficult to replicate without using tools like Grasshopper. So hopefully you find this useful and you see the power of this tool. If you have any questions, make sure to let me know. I'd love to answer any questions for you, and I post videos like this where you can learn exercises and techniques to make progress and learn more about how parametric design works and how you can use them for your designs.